Welcome to the demo of PSSE Xpress. I am Ya-Chi Lin from Siemens Power Technologies International. For the next few minutes, let me show you how PSSE Xpress is an essential power flow analysis toolbox. To begin with, do you have any of these issues? Issue number 1. Are you on a tight budget but still need to comply with the NERC modeling standards? Issue number 2. Do you need to model your system right the first time instead of repeatedly going back and forth to correct your system models? Issue number 3. Is your regional independent system operator ISO or neighboring utilities using PSSE? Issue number 4. Are you concerned about learning new software? If you can identify with any of these problems, we have a solution for you. If you are on a tight budget, how about modeling and analyzing your network for less than $11 a day? If you want to get modeling done right the first time, well, PSSE Xpress will be very useful. Compile a trustworthy model with a proven technology that all major ISOs and regional transmission organizations have already been using and which has proven accurate for many years. Since your regional entity, ISO or neighboring utilities already use PSSE, of course, you can speak the same language with them using the same software so you can avoid any conversion or translation errors. Are you concerned about learning new software? Well, everybody is. How about using the software that is intuitive, Windows-based, and developed by engineers for engineers? Put all these together. Here is how PSSE Xpress can help you. Now, let's take a look at how to build a consistent and meaningful model. First of all, why do we need a consistent and meaningful model? In order to study and plan your system for the future, you need to establish a system representation of the equipment you currently have. Based on the existing model representing the current state, combined with the knowledge of the growth pattern, you can forecast the future. Your ISO or regional entity already builds the cases for the neighboring regions. You can choose to either import a case from them or you can build your own. This is what we call the first step, model development. If you choose to start from the existing case, open it up and you can edit it to include more details, or you can modify whatever is inconsistent with your actual equipment. After the model is built, the next step is solving the power flow. The purpose is to find out the operating point based on given network conditions. In the next step, validate the data. This step is to find out if you entered the data correctly or if the data was inconsistent with the actual equipment. Finally, after you make sure that the model is accurate, you can proceed to reporting. In this step, you can analyze bus voltages, real and reactive power flows. Furthermore, you can identify any potential risk to system reliability and use the information to plan the system accordingly. Following all these steps, you can deliver the accurate system representation to your neighbors and your ISO or RTO. This is the typical workflow from importing cases through model development, power flow solution, data checking, and export. But wouldn't it be nice if you could have a tool to pull together the whole process? We'll talk more about process automation in a moment. So, why PSSE Xpress? How can PSSE Xpress help you address every single step? Let's start with model development. In this step, PSSE Xpress is capable of importing and exporting power flow data. So you can start either with an existing case or you can start building a new one. If you need to exchange models with your neighbors that use PSSE, PSSE Xpress has identical data modeling capabilities. Or if you need to merge the system modifications from different sources, PSSE Xpress also has built-in functions to address this need. It is very likely that the case you receive from your ISO will be very large and will include the entire interconnected system. You can use the subsystem selection in PSSE Xpress to concentrate on your area. Next step is Power Flow Solution. PSSE Xpress comes with both Gauss-Seidel and Newton-Raphson solution methods. To help investigate difficult-to-solve cases, a non-divergent solution option is also included. All these solution options are flexible and user-friendly. They can be fully controlled by the user. Next step is data checking. You can validate Power Flow data entry with built-in activities in PSSE Xpress. PSSE Xpress provides you with several activities to ensure network conditions and equipment ratings are indeed within normal ranges. All these data ranges can be customized, or you can use our default values. Reporting. We have over 40 one-click reports. Here is a small sample of what you have readily available, such as bus voltage and branch loading violations. You can also use the reporting activities to find out individual generator conditions. If your system is connected to other neighboring areas, you can check the tie line flows. You can even compare the power flow cases. To help users better understand their systems, PSSE Xpress includes extremely versatile visualization. A picture says so much more than many lines of words. The visualization is even extended to Google Earth integration. Here are examples of what PSSE Xpress visualization looks like. The screen on the left is the PSSE Xpress interface. The one in the middle is with contour plotting showing the network conditions. Note any area in yellow or even red. These areas show there could be potential violations. On the right is the network information integrated into Google Earth, so you can see the actual geographical location of the system. To tie all the faces together, PSSE Xpress has two very powerful tools. One is process automation. The other is our user support. For the process automation, you have the ability to record and play. So next time, all you need to do is to push a button and play that recorded file. And every step of the process that you have just recorded will be conducted automatically. This can be done through Python scripting. You can expand the automation for a complete series of activities. PSSE Xpress has an unrestricted number of buses, which means the PSSE Xpress can handle a case as large as the Eastern interconnection. After you have purchased the software, how can we keep you updated on the latest and greatest information about PSSE Xpress? There are numerous ways to do that. To begin with, if you have questions, you can contact our customer service through email or by submitting an inquiry form online. You will also have access to our exclusive support website where you can find the latest information and latest release available for download. Admission to our annual PSSE user group meeting is complimentary. We invite our users to meet once a year in each region to communicate with each other. This is the place for us to share with you our latest developments in PSSE Xpress. Now, where do we go from here? if you need to verify whether or not the fault currents exceed the breaker duty. You can expand to include short circuit calculation capabilities with PSSE Xpress Plus. Start by adding unbalanced system modeling data to the safe cases. You can simulate different faults at any bus or transmission line on any phase. For example, 3-phase to ground fault, line to ground faults, and many more. Our PSSE Xpress Plus follows both ANSI and IEC standards. Let me give you a brief demo on how to use PSSE Xpress. PSSE Xpress is started in a manner similar to any Windows application. Start, Programs, find Siemens PTI. Then you will find PSSE Xpress. You can see that there are multiple tools to help you. For example, documentation, utilities, and more. You can even access the Siemens PTI user web page through the shortcut which is included here. Let's start the software. When we first open PSSE Xpress, the dialog box pops up to remind you that some of the activities are grayed out because those functions are only available in the full module of PSSE. You can click the Don't Show Me Again box. It will go away and won't bother you again. This is the interface of PSSE Xpress. On the top is the menu bar, followed by rows of toolbars available for shortcuts. On the left-hand side, this is the tree view for summary of the network elements. At the bottom is the progress and report window. The progress and text report will be shown in this area. To import a case, click File, Open. Just as you would run any other Windows application, I am going to start with a very simple case called savenw.solve. Notice how PSSE Xpress takes you to the example directory. Every installation comes with an example directory. In this directory, you will find numerous PSSE Xpress sample files. So, if you like to see examples and explore different functionalities, they are all available in this directory. Now that the file is open, let's move on to the model development phase. At this point, you can modify the case to better represent your network. For example, a load in your system may grow 10% in the next 5 years. This load, currently 200 megawatt, is located at bus 153. To plan for the future, the load will grow from 200 megawatt to 220 megawatt. You notice here that I am typing in the value manually. PSSE Xpress also has the activity to scale the load automatically by a different power factor or percentage. After you added the network, you need to solve the power flow to find the new operating condition. You can do this by going through Power Flow, Solution, Solve. When you click this button, the dialog will pop up and ask you to choose the solution method. For our demo, we will use the default fixed-slope Newton-Raphson method. Click Solve, and then Close. You will see that there are lots of text in the progress window. This is the conversion monitor. For each iteration, the message indicates where the largest mismatch appears. The message at the end shows that the tolerance is reached. That is, the network is capable of supporting the extra 20 megawatt of load. The network is stable and finds a new operating point. Moving on to the next phase, data checking. What can you check? Go to Power Flow, check data. Since this is an existing case, you may want to find out what the controlled buses are. For example, what is your generator controlling and the voltage step point? PSS Express can list the controls in the entire case or just the subsystem you are focusing on. You can customize this report to your own needs. Once you click Go, you will see a new screen popping up. In this screen, all the controlled buses will be listed with their detailed information. Let's go to the last step, reporting, to help you understand the network condition. There are many reports that you can run. Let's go to Power Flow Reports Limit Tracking. Let's check on a very common application, voltage, to see if any voltage is beyond plus minus 5%. That means minimum 0.95, maximum 1.05 per unit. Click Go. You can see a new report comes up. There are 2 low voltage violations. Bus 154, the new voltage is 0.9386 per unit, or 215.89 kV. And bus 205 at 0.9488 per unit, or 218.21 kV. At the very end, how do I export the case? Let's click File, Save. You can save it under a different file name, or you can choose any of these formats PSS Express works with. Now, this is how we run the program in the text format. You can also complete the whole operation in diagrams. The diagram format is called slider file. You can open the slider file through File, Open. Make sure you choose the slider file. I'm going to open the savenw.sld file to go with our sample case. This is the slider file representing the network. In order to have more working area in the diagram, you can choose to hide the tree view and the diagram view. When we reported the voltage violation earlier, we read the violation report in the text format. Now, let's see how this can be represented in the diagram. We can choose contour plotting. I'm going to enable the diagram to contour based on bus voltage. The idea of contour plotting is simple. The higher the values, the hotter the color. And the lower the values, the colder the colors. So, for high voltage at 1.1 per unit, I'm going to color it red. And for low voltage at 0.9 per unit, I will color it blue. You can see that the upper part of the network in the slider diagram has very high voltage, since the diagram is mostly red and orange. On the lower part of the diagram, the color is very cold. We may potentially have low voltage violations. You can make these kinds of representations either through the text or diagram. The whole process can be tied together with a Python program. You can record every single step as you go along. Then next time, all you need to do is to run the recorded file instead of operating it step by step. PSS Express has many more functionalities than those we saw today in this brief demo. For more information on PSS Express capabilities and PSS Express Plus, tailored to your specific needs, please contact us. Thank you for your time and patience.